Hi guys, welcome to another video. And it's the ninth video in our Terraform series, Infrastructure as a Code. We've been looking at modules. In our last video, we looked extensively at modules where we configured both the custom modules and also we configured modules from the Terraform registry. So today we are going to look at another chapter, which is the Terraform backend. Now, when you think about the Terraform backend, in Terraform, when you have sensitive values, the question is, how do we deal with sensitive values like passwords and all that? So when you run Terraform commands with a local state file meaning you're storing your state file in your local environment, in your computer. Terraform stores the state as plain text, right? It stores it as plain text, including variable values, even if you have flagged them as sensitive. So Terraform needs to store these values in your state so that it can tell if you have changed them since the last time you applied the configuration. So that's why it stores everything in plain text. So since Terraform state can contain sensitive values, you must keep your state file secure to avoid exposing this data, right? So that's why we need to be careful how we manage our state file, because the state file, it stores everything in plain text, and therefore if everything is in plain text, if it has sensitive information, it can easily be exposed. That's why we have now what we're talking about, a backend. So when we talk about a backend, each Terraform configuration can specify a backend, which defines exactly where and how operations are performed, where the state snapshots are stored, etc. So if a configuration includes no backend block, then Terraform defaults to using the local backend, which performs operations on the local system and stores state as a plain file in the current working directory. So that's what we've been talking all around. If you don't configure a backend in your Terraform block, right, then Terraform will use the local backend. It will use that local backend as your storage for your state file. So when changing backends, Terraform will give you the option to migrate your state to the new backend. This lets you adopt backends without losing any existing state. So you can change your backend configuration at any time. So you can change both the configuration itself as well as the type of backend. For example, we have a number of examples that Terraform uses as backend. So for example, if we just look at overview of the backend and the configuration, then these are the available backends. You can use local, you can use remote at factory, Azure, remote console, cons, etcd, GCS. So all these, but we'll be focusing on S3. All these are backends that you can configure, right? Backends that you can configure so that you can store your state file. Now, Terraform will automatically detect any changes in your configuration and request a reinitialization. As part of the reinitialization process, Terraform will ask if you'd like to migrate your existing state to a new configuration. This allows you to switch from one backend to another. So if, let's say, we are working with a remote, rather with a local backend, we have our Terraform state stored on our local. Then we want to migrate it to S3. So once we configure a backend, then what is going to happen is Terraform is going to sense that and it's going to give us the option to, if we want to migrate our state to S3 or want to migrate our state remotely, right? Now, as we'll be looking at S3, For the S3 backend, we'll configure it so that it has locking. We lock it with DynamoDB tables. So S3 basically stores the state as a given key in a given bucket. We store it in a backend. This backend also supports state locking and consistency checking with DynamoDB, which can be enabled by setting the Dynamo table field to an existing Dynamo table name. The single DynamoDB table can be used to lock multiple remote state files. So Terraform generates key names that include the values of the buckets and keys variable, right? So we will be configuring this backend with DynamoDB state locking, right? DynamoDB state locking, and whereby now we can have our Terraform state file stored in an S3 bucket. But then the reason why we use DynamoDB locking is because we don't want data corruption. So imagine we store it in S3 because it is a distributed environment. We can have more than one engineer working on the state file at the same time because it is in a distributed environment. So that means you can have multiple people accessing the state file. But if that is the case, then there is a possibility that your state file can be corrupted, right? If you have multiple people running Terraform apply, or one person is running destroy and the other one is running apply, and they are working on the same state file, they're using the same file, chances are there's going to be data inconsistency or infrastructure drift. So with that, so we do a state locking. So when you lock the state using DynamoDB, then it can only allow like one person to be working on it at a time, right? If one person is working on it at a time, then with that, it is going to prevent any data inconsistencies from happening. So if we go to our data backend or remote state, okay. So inside this, I have my data source, right? My data source. Then we are going to create a basic EC2 instance, just an instance. We're going to use the data source for our AMI right here. And the only variable we are passing here is our instant type, right? Because this is the only variable that we've passed as our instant type. It's a very basic configuration. But now for our backend, so this is our Terraform block, right? It's our Terraform block. Now, inside of this Terraform block, we are now configuring a backend. Now, this backend, it is S3. This is the configuration. This backend is S3. Then you have to put the bucket name. This is the name of the bucket. I've already created this bucket. Now, if you haven't created the bucket, you can create it as a resource, right? And that bucket needs, the SCL needs to be private, right? Because you don't want it to be publicly accessed. And versioning, you have to enable versioning because of the multiple Terraform, once you apply, you need to version your state file for easier rollback. Then the key, this is just a directory where you'll be storing the file, the state file, which is just a path. You create a directory, and this will be the state file that will be stored in. But now we are equally locking this backend with a DynamoDB table. And the name of the table is this Terraform lock. And the region where the bucket is US West 1. But we have to create this lock as a resource. So we are creating this DynamoDB lock, and the name is just TF lock. But the name of the DynamoDB table is Terraform lock. So all this configuration, you can find it in your resource, the resource block for an AWS DynamoDB table, right? and the hash key is loc ID. Read capacity is 3, write capacity is 3. Then the attribute, it need to have the name loc ID, and it's a type S, type string. Then this is just the tag, right? Then I've put a life cycle, prevent destroy equals to true. So this is a life cycle that protects this lock from accidentally being destroyed. You are preventing it from being destroyed equals to true, right? Basically, this is my provider block. So now, if we go ahead and run this, so it is going to, the first thing when you initialize, it always initializes your backend. So it always initializes your backend. But let's do something. Let's initialize this, right? Let's initialize this without this backend so that we have our step file saved locally. And then we will reinitialize it with an S3, and let's see what happens. So with this, I can just comment this. I can comment this backend. Right, I can comment it right there, like that. I can comment it right there. But then for this, I'll need to put one right here. I need to close this. So 1, 2, 3, 1, 2, 3. Okay. So I've commented this. I've commented this bucket because this bucket already exists. But if your bucket doesn't exist, then you can create the bucket first. So let me save this. If I just save, and let me go now to my terminal. On my terminal, let me see I'm in the remote state, Terraform backend 08. I'm in the remote state, VPC module. Now I need to go back to my remote data state. So I need to cd back. I need to cd back and go to remote from VPC. I need to cd back. Okay. I'm in a remote state. I'm in a remote state, and then let me go to remote state. CD remote state data source. Okay. So now I'm in this remote state data source. Right here, I need to go remote state data source. So if I ls, I'm gonna see the remote backend. So I need to cd into remote backend. Remote backend. If I ls, I should be able to see this 4 files. Okay. So now with this 4 manifest files, I'm gonna run Terraform and so an admin block definition required 950. Okay, backend. Source 1, 2, 3. 1, 2, 2. This closes here, that closes here, this closes here. So this 1, 2, 3, 4. 1, 1, 2, 3, 4. So I need to check this out. Maybe. Then I'm going to save it. Let's see. So let me initialize it. So right now it has initialized. It's initializing the backend. And when it initializes the backend, you see it is saving everything. This Terraform log, it is basically saving it on my local desktop. It has downloaded this Terraform provider, the Terraform provider, like it has downloaded it on my local environment. Okay, so if I go ahead and run Terraform apply, let's total, let's approve. So now we see it's downloading the Terraform state log. It has downloaded the Terraform. It is now creating the Terraform state file right here. It is creating the state file right here. While it's still creating, it's creating the DynamoDB, it's creating the log, and then it's gonna create the instance. Now remember, this instance, it's creating it in the default VPC because we just created a basic instance. We didn't pass any subnets or where we wanted to create, right? Where we wanted to create. So we just created an instance, but the only thing is where our Terraform state file is now stored. We can see it right here. It is stored on our local environment. This is our state file. Okay. So now let's go back in. Let's go back inside our backend, and now let's uncomment this backend. Let's uncomment this backend and check this out. Uncomment this backend and let's initialize it. So as we said, initialization, the first thing it does is it always initializes the backend. So if we do that, if we uncomment that, then let's try to run Terraform apply again and see what will happen. So once you run Terraform apply, again, it is going to refresh the state. Okay, now it changes the infrastructure. So let me save because I just made a change in my backend. So let me save it. If I save this, then let me run Terraform apply. So once I run Terraform apply, it's going to give me an error. Why? Because right now in my Terraform block, I have passed a backend, which is S3. But this Terraform state is stored locally. So it is going to give me an error saying the backend initialization is required. Please run Terraform init, because reason initial configuration of the requested backend S3. So because Terraform has sensed that I'm changing my backend is now no longer local, it will need reinitialization because it has to configure this backend. So with this, you have to run Terraform init first. Whenever you're changing your backend, you have to initialize it because that's the first thing that Terraform does. So I'll run Terraform init. So once you initialize it, it now initializes. It's now initializing the backend, and it will give you an option. Do you want to copy the existing state to a new backend? So my existing state right now is local. Do I want to copy it to the S3? So you enter the value yes. Once you enter yes, then once you enter yes, then now it is now going to copy the S3. It's now going to transfer your state from your local to S3. Now, if I try to open this state file, you see it is blank. It is blank. We don't have a state file anymore here. This state file has been transferred to S3. So now if I go to my console, let me see. If I go to my AWS console, S3, and the bucket name was my Terraform state, I'm on bucket. If I open, I will see this directory Terraform, right? If I open it, I will see Terraform state. If I open it, this is the Terraform state. If I open the object, then I will see now this is my state file. This is now the state file that has been migrated to S3. Now this state file is just created on Amazon Linux server, right? So this has now been migrated to S3, and this is the DynamoDB table that I created, right? So basically now my state file, it used the data source. It used the data source to basically create that instance. But now everything has now been migrated to the S3, right? Which is now remote. So if I go back to this, but this instance is basically being created in a default VPC, right? Because as I said, we didn't pass any network that we want to create. So it will create it in a default VPC. So with this, I will go ahead and run Terraform destroy, Terraform destroy, auto approve. Now when I run it this way, because I have put a prevent destroy on the lock, so that lock will not be destroyed, but it was created as a resource. So if I want to basically destroy it, okay, let me just run that. So it is going to destroy, just refreshing the state, and then it will destroy the EC2 instance. But here it says that the instance cannot be destroyed. Why? Because I had passed this state lock. I passed the state lock, right? I passed the state lock on the instance on the backend, and in this backend, I put a life cycle prevent destroy equals to true, right? So it has a life cycle prevent destroy set, but the plan calls for this resource to be destroyed. To avoid this error and continue with the plan, either disable lifecycle prevent destroy or reduce the scope of the plan using the target flag. So releasing the stock may take a few minutes. So this is now how you can prevent a resource from being destroyed, right? A resource from being accidentally destroyed. You're going to use the life cycle. You can pass a life cycle, prevent is equals to true. So now with this, what I can do, I can pass Terraform. I can say prevent. I can just say false, and once I save, I can now run Terraform destroy. Terraform destroy. So that should now go ahead and destroy. Should not go ahead and destroy everything. But remember that state file, it has a DynamoDB lock key, right? Lock key. So my expectation is that it might give us another error because of the key. and next we pass the log equals to false, right? Log equals to false. Yeah, this is the error releasing the state log, right? Error message, failed to retrieve the log info because we were running destroy. Basically the log, the DynamoDB table log was destroyed, and because we had locked this bucket with this key, with this log, but the log has been destroyed. So now there's an error releasing the log. So what we do now, we have to pass -log equals to false, right? Log equals to false. So you can say -log equals to false. So we can run it, and once we run it, destroy complete, right? 0 destroyed. So if I run it again, Terraform destroy auto approve, should be able to tell our destruction complete. Now if I go back on my S3 and refresh this, now I have an error because inside the bucket there is nothing. So if I go back to my bucket, I have the directory that was created. If you go to the state file, if I try to open it, so basically that state file is empty, right? The state file is empty. Because all the resources were deleted. So it is the same thing as if we were running it locally. If you are running it locally, then you will see that the state file is basically empty here. But in this case, state file was migrated. It was migrated. So now this is how we are able to use S3 as a backend. Now, as I said, in this example, we were still creating our EC2 instance in our default network. Now, for the next example, okay, let me just go ahead and delete this first. Move to trash. Let me go ahead and delete this backup. Let me delete this. Delete all. So delete this. Okay. So in the next example, so we will see now, I can create a VPC. I can create a VPC first, just like what we did in the last video. So we can create now a VPC. So in your environment, you might have your network set up first. Like you'll have a VPC configured. And then now you are supposed to create a resource inside of that particular network. So now this is what we call remote data source, right? You are using the existing state file, right? You are using the existing state file that has already been configured. The network has already been configured, but now you are creating resources inside of that. So let's say maybe the management owns the VPC. They manage it. They have their state file saved in an S3 bucket. But then you come and provision, you are tasked to provision a resource inside one of the subnets. So you are going to use what we call a remote data source. You're going to use a data source to get information about that particular state file or to get information about that particular network, and you will just provision your resource inside of that network. All right. So this is what we're going to do. We will now create our network first. We'll create our network first, which is our VPC. And once we have our VPC created, then we will create what we're calling a a data source, we will create now our EC2 instance inside of that VPC. So if I go to this remote state data source, we are going to create our VPC. Now, for this VPC again, for our backend, we've configured our backend as our S3, the same bucket. We have that particular bucket which we already created. So I'm just going to comment it because the bucket already exists. I'm going to comment it right here. Right, comment it. It has the log, and that is the region of provisioning. Then we have these generic variables like the region where we're going to provision it, the environment, and the business division, right? Business division where we're going to provision our resources. And then the local values, again, we have business division, and the environment. We went through this yesterday. This is the same code from yesterday, from our last video. The variables we are outputting: VPC name, CIDR block, availability zones, and all this. Then on our module, we're using this particular module, right? The same thing as yesterday. We have our outputs. We have a Terraform with tier vars, right? The tier vars. Then the auto.tier vars. These are like the subnet. So we are creating a 3-tier network first. 3-tier network meaning we have public subnets, private subnets, and database subnets, right? Those are the 3 layers, the 3 tiers of how we run our infrastructure, right? So we are creating this network first. Then we will, after the network has been created, then we will go ahead and now create our resource. So if I go back onto my terminal, and I will cd back Terraform backend, also 1, 2, 3, 4. I'll cd back. I'm on YouTube, so go to 009, cd into 09, remote state data source. Remote state data source. The ls are going to remote state. So the ls right here. I have this directory. So I'll go ahead and now initialize. I'll run Terraform init. So once it initializes, it has initialized the backend, which is the S3. It has downloaded the VPC module, and now it's downloading the plugins. Okay. It is downloading the plugins. So right here, it has successfully configured our backend and the plugin. So now let's run Terraform. Terraform apply. Auto. Error. Terraform requires a state log to protect the state. So the state log. So the DynamoDB. So we need to create this first. We need to create the log first before it initializes. So what we're going to do is, I'm going to create it locally. I'm going to create the state file locally. So how I do it is that I will comment this. I will comment that, right? And I will initialize. Once I comment that and save, then I will initialize. I'll initialize it again, and then backend configuration has to take it, which you're migrating this thing. So I will reinitialize it by reconfiguring it. So I'll run Terraform init dash, or if you wish to attempt automatic migration of the state, say dash migrate state. So I want to migrate the state from S3 migrate to back to my local, right? So it is now reconfiguring previously S3. So now it is now configuring it, and now it has downloaded this and the log inside of your local. So now with this, I can run Terraform auto or Terraform apply as auto as approved auto approved. Now the reason why I'm doing this is I want it to create for me this lock, DynamoDB lock, so that when I initialize the backend, then it is going to do it. When I initialize the backend, it is going to lock the backend with that lock, right? So initially it couldn't find this lock. So it is creating all the subnets, it's creating everything. Still creating the NAT gateway. It takes a while to create. Okay. Still creating. If I go onto my AWS console, and go to with my VPC, you should be able to see this HR staging my VPC. So this is the VPC that has just been created, right? This is our VPC that we just created. When you look at the subnets, all these HR staging, all these are subnets that is creating HR staging. So it has created private, public, and DB subnets. So it has created them, and it gives you the region where it has basically created them. So now it has created this resource for us. It has created our network. With that said, it has outputted for us. These are our subnets, private, public subnets, and this is the NAT gateway, the IP address for the NAT. Now with this, we have our state file saved locally, and that's why we can see it here. So because now we have the lock, so let's go back and reconfigure our backend. I'm going to reconfigure my backend, and now I'm going to initialize my backend. So with that, because we are reconfiguring the backend, we have to initialize again, right? We have to initialize. If I go ahead and save, if I go ahead and save, if I go ahead and save, because I've just made a change, if I save, and if I don't initialize and just run Terraform auto apply, it will give me an error because it is sensed that I'm reconfiguring my backend. So I'll need to initialize. I need to run Terraform init. Once I initialize, it's now initialized in the backend. Then it will ask me if I want to copy that particular state file to my S3. So I'll say yes. So once I say yes, then it's gonna use the log, release the state log, because now it has the log, and it's gonna now transfer everything over to S3. Okay. So now everything has been transferred over to S3. So if I go to my S3, and I look at this is my bucket name, and I look at this state file. It's now there. If I open it, then now here you see I have my state file, right? I have my state file. So this is now in a distributed environment whereby anybody, any engineer who has credentials or access to this account, they are able to see this state file. And because they have the state file, and because our code is in our source code management, which is also distributed, they will have the same code that I have, and they will have the state file. And therefore they are able to manage resources equally, right? They are able to manage the resources equally, because if they run the same code from their environment, the configuration is the same. So they will still be talking to this state file. And that's why we have to lock it such that if I'm working on it, then somebody else shouldn't also be working on it, because otherwise it will be inconsistent, right? So with that, now I've created my infrastructure. If we looked on the console, we have our network created. Now, so that because now we have our network created, now we need to create now our EC2 instance or our resource inside of this network. So how do we do that? So for us to do that, we're going to use what we call a data source, a remote data source. Okay. So for a remote data source, one of the things is right here, we are basically creating an EC2 instance. We're using a data source for an AMI. But when on the EC2 instance, we are passing, this is our Terraform block. Remember, here we are not passing any backend. So therefore, the expectation is it is going to save this state file locally, right? So we have our provider, but then we have this data block. The data block, it is called Terraform remote state. This is the resource type, Terraform remote state. We are using this data block so that it calls a remote state, and you can give it any name. This name I've just given it as network. Then you have to put the configuration, like where is that remote state that we're trying to access. So I can say that my remote state, it is in a backend, which is S3, and the configuration of that backend is, this is the bucket name, okay? This is the key, like this is the path where that particular folder is, right? And this is the region. So this Terraform, it will go and try to get information about this state file. So it will get data. We are trying to get data from that state file that has already been created, right? So this is if your backend was in S3. Now, if your backend was local, you can equally use a data block and the backend is local. And config, you can just give it a path, the path to where your remote, your Terraform state file is. So this is now how you use a data source to call data from your local backend. And then for our resource, we are creating an instance, but we are using an AMI as a data source. This is the instance type, but now we are creating it in a subnet. And the subnet that we are creating it is in, we are using this data, right? This data block, the resource type is this Terraform remote state. The resource name, it's .network, right? And we want to get from this data source, we have outputs, right? We have outputs. When we created this VPC, we had VPC outputs, right? We had VPC outputs. And for our VPC outputs, some outputs, we had like public subnets, we had private subnets. So we want to create it in some of these subnets. So we will go to our output block, and if we choose like a private subnet, this private subnet, remember, it is a list of IDs, right? It is a list of IDs for private subnets. So what we do is that now we will give it as a list. We are saying we are creating this under outputs in a private subnet with index 1, because we are creating two subnets. We are creating our subnets in West, in 1A and 1B. So now we are saying we want to create this instance in this subnet 1C, which is at index 1. If we wanted to create it in the first subnet, we will say 0, because we remember the index starts with 0, 1, 2, 3. So we are creating it in our first subnet, right? So now with this, we are now referencing the infrastructure that has already been created, but we are getting data using a remote state. We are getting data, and therefore we are just creating resources in the infrastructure that already exists. So, as a matter of fact, this is the situation where what you will be expected to do. You will not always be expected to create your network. Your network will be there already existing. Or let's say this network could be your production environment. They have configured everything. But you, in the development environment, you are tasked to create a resource, right? You are tasked to create a resource. So once you create that particular resource, then you're just using the existing infrastructure to create your resource inside of that infrastructure. And as you create that infrastructure, you will equally have your own state file. So you are not mixing up the state file. This infrastructure or the prod environment, they have their own state file, which is managed in S3. Now you will have your own state file, but you're just using their infrastructure, but you will manage your own state file. Because if I run this, it is going to store my state file here locally, right? But I can equally configure a backend here and give it a different bucket name. I give it a different bucket name. So with that, it is going to store now the state of this infrastructure in a different bucket. Or I can configure the same bucket. It can be the same bucket, but I can just give it a different path, right? It will create a different directory. Let me say, maybe I can create a path like dev, right? Dev/Terraform. So it will create in the same bucket, but just on a different directory. It will store the state file for the dev environment. Okay. So now this is how we are able to separate the state, but yet using the same infrastructure. So we are going to use Terraform remote state. We use data blocks, right? Data block to configure. So now let's go to we have our infrastructure running, right? It has this state file right here that is empty because it is being hosted in S3. So let's go back to to our remote data source. All right, here, if I ls, I'll need to go to the remote data source. The remote data source. Inside there, I just have these two files, right? Remote EC2 and remote data source. So right in there, I will do Terraform init. So I will initialize. Once I initialize, it's now initializing the backend. And the backend for this is just right here remotely, right? It is local, right? It has initialized, just downloaded this Terraform log here locally. Then I can run Terraform. I can run Terraform approve or apply does auto approve. So once I run that, you see now I have my state file created right here, right? I have my state file down here. It's still populating. I have my state file. So it's still creating the instance. And where is it creating? It's creating it inside of this network, the VPC that I created. So it is just basically just still creating just an EC2 instance. So it has added that. So if I go to my console, and look at my EC2, look at the EC2, got my EC2, then now here I see this one instance that just created. This my EC2. It's initializing. That's the IP. Let's look at the subnet. The subnet ID is created in the subnet called HR, staging my VPC private subnet, right? Because we selected one to create it in the private subnet. So now it has created in this private subnet. And because it's a private subnet, you realize that it doesn't have a public IP, right? It only has a private IP because we are creating it in a private subnet. Now, if I wanted to create this instance in a public subnet, then all I'll need to do is now go back to my EC2, go back to this, that where am I creating it? I will do the output. I want to create it in the public subnet. And with public subnet, let me say public subnet 1, because I also have two public subnet. So if I do that and I save, then once I save, I go back to my command line and I run Terraform apply. It is going to send the difference. Then what is going to happen is it is going to destroy the instance and recreate it, right? So it's going to change. It's going to destroy it because it had been created in a different subnet. Then it's not gonna recreate it. So if I go to my console and I refresh, I see that instance has been terminated. That instance has been terminated, and now we have this one that is just coming up, right? That is just coming up. And as you see, it now has a public IP address because it's in the public, created in the public network, HR public US West. Now this network, right, is public, and this network was created when we created our VPC, right? When we created our VPC. When we created our VPC, we created this VPC, and now it's being created in this subnet, this public subnet. Inside this public subnet, US West, this one, public subnet US 1C. So now that instance has been created in this particular subnet. So this is now how we're able to manage the state file for this VPC is being managed in S3, but yet the state file for my EC2 instance is being managed locally, right? This is the state file. It's being managed locally. It's on the local. But again, as I said, you can equally configure backend so that you send this in S3, right? You can equally send this in S3. So you can play around with that. Now, if I go back, right now I have my instance running inside of that particular network. So let me see if I go back now and try to destroy my network, but with the instance, all this I've created inside of that network, what is going to happen? So let me go back to remote data source. Let me go back, cd out. Let me just cd out. So I'm in the remote state data source. If I ls, I'll see all this. So let me run Terraform destroy -auto -approve. Then I pass --log equals to false because it's log. It's refreshing the state. It's trying to destroy that. So right now I'm destroying the network. Destroying the NAT gateway. It's destroying this. It's still destroying. we realize it is stuck on this public subnet 1 on the internet gateway. It says it's still destroying, but the rest took only like 1 second. They took like 1 second to destroy. Well, but see what is happening here. It's still stuck on destroying this public subnet, right? On the internet gateway. Why? Because these resources, there's an EC2 instance that is tied to this. There's an EC2 instance that is running inside of this particular subnet, right? And the EC2 instance, it has access to the internet. So that's why now it's taking a while to destroy. But let's see what is going to happen. It may just time out, or it might give us an error because if you have an instance that is running, inside of that network. So it's running. So it basically will not destroy it because you have an instance running into it. So for us to be able to destroy it, we have to destroy our instance first. We have to destroy the resources that are running in that VPC first before we destroy the network, right? Because the resources are attached to this particular network. So I can just kill the process, Control C, then I will go to our CD into remote data source. Then right there, I'll run Terraform, destroy, -auto, I'll run Terraform destroy, so it's gonna destroy the instance, right? And so that will be subnet ID, subnet ID 1, not update is not subnet. Yeah, the output has already been destroyed. So we see now even here, because we ran destroy on the network, it has messed up because it destroyed the outputs from that. So now this state file has now been corrupted, right? Has been corrupted. If I go to this S3, this S3, I look at my buckets. Terraform state. Let me open it. Let's see. Okay. I have that model VPC. You see now, this is all that is left inside of my state file, because everything else has been destroyed, right? I only have left the internet gateway. Then I have the subnet. This is just a public subnet. The index key is 1. I have one subnet left, right? And I have the VPC module. So I have this VPC module left because this subnet belongs to this VPC. So as it was being destroyed, when you run destroy, everything was being taken out of the state file. Once a resource has been destroyed, it is deleted from the state file. So now with this, we see that we only have these three resources happening just because our EC2 instance is running inside of this public subnet, right, which is tied to the VPC. And because it's public, so that's why the internet gateway cannot yet be destroyed. So with this, now on our resource block, we are calling this data, this remote state, right, network with the output. We are calling output as public subnet. But because we ran destroy, it destroyed all this, our data source was destroyed, right? So therefore, even for this second, now in our local, our state file now has been corrupted because we can't access that data. We created this instance. We created this instance inside of what? Inside of the network that was created. So for this, because that output has been destroyed, we actually can't be able to destroy this instance from here. So that's why you need to know the order. If you're running a destroy command, you need to know like what to destroy first. You definitely don't want to destroy your network, right? You don't want to destroy your network. So you can't destroy your network, or you don't want to destroy your network. That will be managed separately, and you need that to exist. But now, if our network was existing, then as we use data sources like this, we are able to create our resource inside of this particular network. So now for this case, I'll just go on my console. I'll go on my EC2 instance, because we just created a basic EC2 instance. And what I will do is, right now it is still running, so I will just terminate it. I'll go to actions, instance state, and I'll just terminate it. I'll terminate this instance. Once this instance is terminated, and I'm just shutting down. So right now it is terminated. So once it terminated, if I look at my configuration, all that I was creating was just an EC2 instance. So now that it has been terminated, and then now I can go to, it has been terminated, and I look at my Terraform remote state, which basically says I have all this inside of this subnet, inside of that subnet, and it's using a data source. And then I can go to I can cd back. I can cd back my ls. Then I can just run Terraform destroy. Applying the state log. So I can say log is equals to false. All right. So because we terminated our EC2 instance, so it is no longer attached to that particular subnet. So now we are able to destroy our infrastructure. Otherwise, it wouldn't allow you to destroy it if you have a resource running. So now we've terminated that. So if we go to our S3, and we now look at our bucket. Now look at our buckets. That's our buckets. Look at our Terraform state. We try to open it. So now our state file is empty. Everything has been terminated. Right. So everything has been terminated. Now with this, I can just go ahead and, because everything has been terminated, so I can go ahead and just delete this. I can go ahead and delete this. I'll delete this. I will delete this backup. Delete the state file. I'll delete the lock. Delete this directory. I'll delete this directory. Delete. All right, so with that, we come to the end of this video. I hope this video has been informative to you. I hope that you take a while and go through the practices. The code will be available for you guys to be able to go through and practice. And the key thing is just always look at the documentation. Always just create a habit of going to the registry and looking at the documentation, looking at what is new, looking at how you can configure different things. So just go onto your Terraform registry, right? Go into your registry and look at the different modules. If you want to create an EC2, instead of creating an EC2 like we did, you can just search for EC2, right? You can search for EC2 module. If you want to create a security group, you can just search for security group an EC2 module. So you can create an instance using a module, and this is how you will reference it, right? This is how you reference it. These are just your inputs, and here it gives you have about 50 inputs. You can read at what you need to, the kind of inputs that you can put in an EC2, then what kind of outputs you can get out of the EC2 instance. Basically how to reference the usage. So you can just go in your documentation, you can just copy this and modify it, right? So if you are using this and you had like an AMI, you can put an AMI here, then you can standardize it by passing all these as variables. So copy this, put it in your code, use variabilize all this, create variables. If AMI, you can use like data sources, right? If it's subnet IDs, you can use data sources, importing data from a different remote state, and basically just learn to use variables, learn to use modules, because this is the standard way in production. This is the standard way of writing code, because once you write a module, as we said on the back end, it is creating all these resources for you. If you go to your source code right there for that particular module, on the back end, this is the code that that module is running. If you go to your main.tf, it is creating all these things as resources. And you see all these things are being passed as variables. So you can put in as many inputs inside of your module, but they will end up translating. You're just making inputs right here, right? You're making inputs right here. And it will become much easier for you, because otherwise, if you were to write from scratch, like writing them, you need to be writing all this. You need to be writing all this, right? Which is it beats the purpose of why modules exist. Modules exist because they are reusable. So practice using modules, right? So thank you for watching. Bye bye.